How'd go, students? In this video, we're going to do the BJC Math Paper 1 exam for the year 2020. Now, the very first thing you must do when you receive your exam is fill out this section. You have your school number, candidate number, initials, and surname. Now remember, this is the BJC Math Paper 1 exam, and you're going to have 1 hour to complete this exam. Now, before we begin to solve this exam, I want you to like the video and subscribe to the channel. And remember, as we're working through these problems, if you have any trouble with any question we're doing, just drop a comment down below. And if you found this video helpful, you can also drop a comment. Okay, let's begin. Now, when you receive this exam, the first 4 problems you're going to encounter is going to be an addition problem, a subtraction problem, a multiplication problem, and a division problem. So we want to make sure we know how to add, subtract, multiply, and divide really well. Let's begin. We're going to start with number 1A. We know this is going to be an addition problem, and we have 3,872 plus 145 plus 89. Now I'm just going to write this in the rough work section. Now let's begin to add this. We have 2 plus 5, that's going to give us 7. 7 plus 9 is going to give us 16. So we're going to write the 6, carry the 1. Now we have 1 plus 7, that's going to give us 8. 8 plus 4 is going to give us 12. 12 plus 8 is going to give us 20. So we have 20. We're going to write the 0 and carry the 2. Now we have 2 plus 8, that's going to give us 10. 10 plus 1 is going to give us 11. We're going to write the 1 and carry 1. Now we have 1 plus 3, and we don't have any more digits to add, so that's just going to be 4. Therefore, our answer for number 1, part A, is going to be 4,106. All right, let's do part B. Now, part B is a subtraction problem. We have 9,873 minus 1,426. I'm just going to write this in the rough work section. That way I have more space to work with. Okay, we have 3 minus 6. We know 3 is smaller than 6. Therefore, what should we do? Exactly, we're going to have to borrow. So we're going to borrow 1 from 7. So 7 is now going to become 6. And what's going to happen to this 3? Well, we know this 3 is going to become 13. Now we have 13 minus 6. 13 minus 6 is going to give us 7. 6 minus 2 is going to give us 4. 8 minus 4 is also going to give us 4. And we have 9 minus 1, that's going to give us 8. So our answer for number 1, part B, is going to be 8,447. All right, let's do number 2, part A. So number 2, part A, is going to be a multiplication problem. We have 239 multiplied by 8. Now, to solve these types of problems, of course, you're going to have to be very good with your multiplication table. We have 8 times 9, that's going to give us 72. So we're going to write the 2, carry the 7. We have 8 times 3, that's going to give us 24, right? 24 plus 7 is going to give us 31. We're going to write the 1, carry the 3. Now we have 8 times 2, that's going to give us 16. 16 plus 3 is going to give us 19. So we're just going to write 19. Therefore, our answer for number 2, part A, is going to be 1,912. Okay, now part B is a little different. We're actually going to be dividing this time. We have 5,649 divided by 7. I'm just going to write it in the rough work section. So we have 5,649 divided by 7. 7 can go into 5 0 times. 7 times 0 is going to give us 0. We're going to subtract. 5 minus 0 is 5. We're going to bring down our next digit, which is 6. Now 7 can go into 56 how many times? Well, we know 7 can go into 56 8 times. We know 7 times 8 is going to give us 56. We subtract. 6 minus 6 equals 0. 5 minus 5 equals 0. We're going to bring down our next digit, which is going to be 4. 7 can go into 4 0 times, so we're going to write 0. 7 times 0 is going to give us 0. And we subtract, we have 4 minus 0, that's going to give us 4. We're going to bring down our last digit, which is going to be 9. 7 can go into 49 7 times. 7 times 7 is 49. When we subtract, we're going to get 0, 0. Therefore, our problem is now complete. So 5,649 divided by 7 is going to give us the answer 807. Now number 3 says write 120,506 in figures. So this is a pretty big number, right? You might have to read it more than once to try to figure out what they're asking. So let's read it one more time. It says write 120,506 in figures. So they want us to write this word form in numbers, right? Basically, that's what the question wants us to find. Now, to write this in numbers, you must have a good understanding of the place value chart. So we have 120,000. So we have 120,000. So I know this is going to be 120,000, comma, because I know after the thousand place, we always have a comma. So we have 120,506. And because we don't have any value for the tens place, we're just going to write 500. We're going to put a 0 for the tens, and we're going to have 6 for the ones. So this number, 120,506, written in words, is going to be 120,506. So this is going to be our answer here. 120,506. Okay, now let's do number 4. Number 4 says a rectangle is 8 centimeters wide and 12 centimeters long. Write the ratio of the length to the width in its simplest form. Now, one of the most important words in this particular sentence is going to be this word ratio. You have to know what a ratio is. The reason is because the question wants you to write the ratio, right? So you have to be able to understand what a ratio is. And you must be able to know the 3 ways we can write a ratio. Now, a ratio is used to compare 2 or more things, right? We must be able to remember that and understand when we see the word ratio, what we are doing. So we're comparing 2 or more things. Now they want you to write the ratio. We must remember the 3 ways to write a ratio. We can write a ratio with the word to. So for example, we can say A to B. We can say A colon B. Or we can say A over B. So the 3 ways to write a ratio is with the word to, with a colon, or with a fraction line. So these are the 3 ways you must remember anytime you want to write a ratio. Now, when we read this question, it says write the ratio of the length to the width. So the question tells us exactly how we're going to write this ratio. Now they want us to write the ratio of the length to the width. So of the length to the width. Now you might be trying to figure out which one is going to come first. Well, notice we have this word to, right? And we just remembered that the word to is one of the ways we can write a ratio. So we know the length is going to come first in this particular ratio. So which side is the length and which side is the width? Well, the question says a rectangle is 8 centimeters wide. So if this is 8 centimeters wide, we know this side is going to be the width and 12 centimeters long, which means this side is going to be the length. Okay, now that we have this, let's compare these two. So we know when we write this ratio in words, it's actually going to be length. I'm going to use a colon instead of the word to width. What is the length? Well, we know the length is going to be 12, but not just 12 centimeters. So we have 12 centimeters, colon, the width is going to be 8 centimeters. Anytime we're dealing with a problem that has units, we must pay very close attention to those units. Because if they give us different units, then we're going to have to convert one of those units. That way we have the same exact units. But in this particular problem, they gave us the same units, centimeters. So now we're just going to simplify this problem. We know 4 can go into 12 3 times, so we have 3 centimeters. And 4 can go into 8 2 times, we have 2 centimeters. So when we write the ratio of the length to the width of this rectangle, we're actually going to write it as 3 centimeters to 2 centimeters. So this is going to be the answer for this particular problem. Let's move on. Okay, we have this one. Now number 5 says, if A equals 10 and B equals 7, calculate the value of the square root A plus B minus 1. So let's write that down. We have the square root A plus B minus 1. Now, we have these letters, and we know the value of these letters because they tell us the value of these letters, right? We know A equals 10 and B equals 7. So everywhere we see A, we're going to write 10. Everywhere we see B, we're going to write 7. So we're going to rewrite this now. A is going to be 10 plus B, and we know B is going to be 7, right? Minus 1. Okay, now let's start to simplify this. We have the square root. Now, even though we have more than one operations going on here, think of PEMDAS, right? When you do order of operations, we know addition and subtraction are on the same level. So depending which one comes first, that's what we're going to do first. We have 10 plus 7, that's going to give us 17 minus 1. Therefore, 17 minus 1 is going to give us the square root of 16. And the square root of 16 is just going to equal 4. So this is going to be our answer for number 5. 4 is our answer. Okay, now let's do this one. We have number 6, and it says use pi equals 22 over 7. Calculate the perimeter of the circle. Now you must remember this. If they ask you to find the perimeter of a circle, that is the same thing as finding the circumference of a circle. So we're going to be using the formulas. And we know we have one formula if they give us the radius and another formula if they give us the diameter. So when you see the word perimeter, when dealing with a circle, that is the same thing as finding the circumference. Now, when they want you to calculate the perimeter of a circle, you must remember the formula. Well, there are 2 formulas you can remember. The first formula is going to be the perimeter equals pi d, which stands for perimeter equals pi times the diameter. So d stands for the diameter. Now, the second formula you can use is going to be perimeter equals 2 pi r, which means perimeter equals 2 times pi times r, which is the radius, right? So in a circle, we must be able to know what is the diameter and what is the radius. In this particular problem, they give us the diameter because they give us a line that passes through the center and touches both sides of the circle, which means this line right here is going to represent the diameter. So we can just use this equation here, which is going to be pi d. Now, just for a quick review, we know if they didn't give us, let's say, this particular part of it, they only gave us from one side. They gave us from the center point to this point on the circle right here. That would have been known as the radius, right? So just remember, the radius is 2 times the diameter. So if you're a little rusty on that, brush up on the parts of a circle. So I'm just going to use this formula, perimeter equals pi times diameter. I'm going to say perimeter equals pi d. Perimeter equals pi. They tell us to use 22 over 7 for pi. So just going to use 22 over 7 multiplied by this d, which is diameter. We know the diameter in this particular problem is going to be 14 meters. Now we know we can simplify this, right? And when we simplify this, we know 7 can go into 7 one time, and we know 7 can go into 14 2 times. We can rewrite this as perimeter equals 22 over 1 multiplied by 2. We're going to have perimeter equals 22 multiplied by 2. When you multiply 22 by 2, that's going to give you perimeter equals 44. And what is the unit? The unit is meters. So we got the perimeter to be 44 meters. So in our answer for number 6, we're just going to write 44 meters. Okay, let's move on to number 7. Number 7 says bisect the angle drawn below. So they want us to bisect this particular angle here. Now to bisect any angle, you're going to need a pair of compasses and a ruler. Okay, now that you have your compass and your ruler, we're just going to put our compass point where these two rays meet, which is going to be right here, right? Because we see where these two rays are going to meet is going to be right at this point right here. So I'm just going to move my compass point and put the sticky end where these two rays meet, right here. Now I'm going to open up my compass. Now I'm just going to put it about halfway. Now I'm just going to draw one big arc to intersect these two rays. You see that? Now without changing the compass points, and now I'm going to bring it this way, and where those two rays were intersected by this arc, I'm going to put the compass point there. And I'm now going to draw another arc to intersect the first arc that was just drawn. So I'm going to put the compass point not here, but right where that arc intersected this line. And now I'm going to draw another arc. Now I'm going to move the compass point and put it where it intersected at this ray. And I'm going to draw another arc. Now right where these two arcs intersect, which you can see is going to be right here. So I'm just going to line up the ruler at this point. We know we're just going to line it up to look like this. I'm actually going to move this dot, that way you can see exactly what's happening. So we want to line up the ruler to go right where these two rays meet, which is right here. And we want to make sure the ruler is going to pass through the intersection of those two arcs we just drawn. So about right there. Now let's just use our ruler and draw the arc. Ta-da! So we have successfully bisected this angle. And this is how you do it. All right, let's move on to the next question. Now number 8 says, complete the chart below. So they give us this chart, and we have percentage, fraction, and decimal. So these are our 3 headers, right? So we're going to have percentage, 21%. For the fraction, they want us to find that, and for the decimal, we have 0.21. So really, for this particular problem, we're just converting from a percent to a fraction, or from a fraction to a decimal, or from a decimal to a percentage, right? We just have to be able to know the relationship between percentage, fraction, and decimal. Now, to find the fraction given 21% or the decimal 0.21, there are two ways we can go about this. We know percent means out of 100, and we know when we look at our digits for the decimal part of this, our last digit is going to end in the hundredths place. So because it ends in the hundredths place, we know that's going to be over 100. So when we write our answer as a fraction, we're just going to write it as 21 over 100. So remember, percent means out of 100, but our last digit, which is a 1, falls in the hundredths place in the decimal place value chart, which means this is going to be out of 100. Now let's do part B. Part B, they want us to find the percentage, but they give us the fraction and the decimal. The fraction is 17 over 20, and the decimal is 0.85. So because we have the decimal 0.85, and we know the last digit stops in the hundredths place, we know we can write 0.85 as 85 over 100. Now, they didn't ask for the fraction because they actually gave us the fraction. They just reduced this fraction to get 17 over 20. But notice something. This 85 over 100 can be written as 85% because we know percent means out of 100. So we have to know what percent means. Therefore, for part B, we can just write 85%. Okay, let's do part C. They want us to find the decimal of either the percentage, 9%, or the fraction, 9 over 100. So whichever way you're comfortable with, you can go with that way, right? Now, I always like to write this in powers of tens. So I know 9% is 9 over 100, so we're pretty much good to go, right? We should know that because we know percent means over 100. Now, when we look at this, we know this is going to be in the hundredths place value column. So our last digit in this particular problem must end in the hundredths place value column, which means this 9 is going to be in the hundredths place value column, right? Not hundreds, hundredths. So therefore, we know we're going to have a decimal point. Then we have the tenths place. Because we don't have any other digit besides this 9, we know we're just going to write a 0 for the tenths place. And 9 is going to be in the hundredths place. So when we write this as a decimal number now, we can write this as 0.09. So for part C, we're just going to write 0.09. Now let's do number 9. Part A says, in the diagram below, find the length of the side marked X. So let's find which side is marked X. When we look at this, we know the length of this side is 7. We know the length of this side is 9. We know the length of this side is 4. This side right here is going to be marked X. Once we've identified the side X, we now have to find for the length of this side. Now when we look at this line, what type of line is this? Is this a vertical line or is this a horizontal line? Well, this is a vertical line, right? We know this is a vertical line. Therefore, I want to find all the other vertical lines in this particular shape. So I know we're going to have this 9 centimeter, and this is also a vertical line. And we have this 5 centimeters, which is also going to be a vertical line. But notice, I know the length of these two vertical lines, right? And when I look at this, I know this is the longest vertical line, which means this vertical line plus this vertical line must equal this vertical line. So to find X centimeters, I'm just going to subtract. So I'm going to subtract 9 minus 5. So I'm going to write this as 9 centimeters minus 5 centimeters to find X centimeters, right? So we have 9 centimeters minus 5 centimeters. When you solve for this, that's going to give us 4 centimeters. Therefore, we know x equals 4 centimeters. Remember, I knew we could subtract because they want us to find part of the longest vertical line. Now, if they wanted us to find this side, right? If we knew the two sides that made up this long side, then we would have added to find the length of this side. But because they give us the total length of the vertical line, which is 9 centimeters, and they give us one of the sides, all we had to do to find this side was subtract these two numbers, and that's how we were able to come up with the answer 4 centimeters. Now, part B, it says find the perimeter of the shape. So this word right here, perimeter, we know is going to mean to add up all of the sides when dealing with a polygon. So remember, when dealing with a circle, we need to remember the formula. And we just did that question in number 6, right? So when we're finding the perimeter of a circle, we must use a formula. When finding the perimeter of a polygon, whether it's a regular polygon, like a triangle, square, rectangle, pentagon, or an irregular polygon, which is something that looks like this, right? We know this is more like an irregular polygon. All we're going to do is add up all of the sides. So let's start at the top. We have 7 centimeters plus we have 9 centimeters plus 4 centimeters plus we know x centimeters is going to be 4 centimeters. So we're going to have another 4 centimeters to represent this x. So I'm going to have plus 4 centimeters plus 3 centimeters plus 5 centimeters. Now we're going to add all of these sides, and that's going to give us the perimeter for this particular shape. So when we add this, 7 plus 9 is going to give us 16. 16 plus 4 is going to give us 20. 20 plus 4 is going to give us 24. 24 plus 3 is going to give us 27. And 27 plus 5 is going to give us 32. Therefore, the perimeter for this shape is going to be 32 centimeters. Okay, let's move on to the next question. Let's do number 10. It says calculate the probability of selecting part A head on a coin. Well, what does probability means? Probability means how likely something is to happen. So they want us to calculate the probability of a head on a coin. Remember, you're going to write this as a fraction, and you're going to write it as the number of ways something can happen over the total number of outcomes. So what is the number of times we're going to get a head on a coin if we was to flip it? Well, we know there's only one side that's going to have a head, so we're only going to have one chance of getting a head, but the total number of outcomes is going to be 2. Because when we have a coin, when we flip that coin, we can either choose a head or a tail. Now, part B says, a red jack from a deck of cards. So we must be able to understand, first of all, a deck of cards, right? If we don't understand a deck of cards, we're going to have a hard time with this problem. Now remember, you have to remember this. The number of cards in a deck is always going to be 52. So there are 52 cards in a deck. Now the probability of choosing a red jack from a deck of cards is going to be 2. Now ask yourself, how much red jacks are we actually going to have in a deck of cards? Well, we're only going to have 2 red jacks. Now we know it's 2 because we understand the concept of a deck of cards, right? We know in a deck of cards, we're going to have 4 different types for each card. We're going to have a red heart, a red diamond, a black club, and a black spade. So the probability of choosing a red jack from a deck of cards is going to be 2 over 52. We know this is 2 because we can either choose a red heart, which is a jack, or a red diamond jack. So that's how we got the answer 2 over 52. Now we know these two are 2 even numbers, so you can actually reduce this probability to be 1 over 26. We're just going to divide the numerator and the denominator by 2. Now number 11 says, draw an example of a ray. So what is array? Well, array is going to be a part of a line that has a start point but no end point. And when I say no end point, that means it goes to infinity. So for example, array is going to look like this. We're going to have a starting point and it's going to go forever in this direction here. So it has no end point. And remember, one of the most important parts about this array is going to be that arrow, because the arrow is going to indicate that this line is going to go on forever in this direction. So make sure you have that arrow. Now, part B says Pentagon. So they want us to draw a pentagon. So you must be able to know what a pentagon is first of all. We know a pentagon is a polygon with 5 sides. So to draw a pentagon now, we must draw a shape with 5 sides. So this is a pentagon, right? We have 1, 2, 3, 4, 5 sides. Of course, you can use a ruler to draw this, right? Now, number 12 says, part A, list the next prime number after 7. So ask yourself, what is a prime number, right? A prime number is a number that has 2 factors, 1 and itself. So let's list some prime numbers. We know the first prime number is going to be 2. After 2, we have 3. Then we have 5. We have 7. And after 7, we're going to have 11. After 11, we have 13, and so forth. Now, the next prime number after 7 is just going to be 11. So our answer for part A is going to be 11. Now, part B says, list the first 2 multiples of 8. So they want us to write the first 2 multiples of 8. So think about it. When they want you to write the multiples of a number, think of the multiplication table, starting from 1. So we're going to say 8 times 1, that's going to give us 8. After 8 times 1, we have 8 times 2, which is going to give us 16. After 16, we're going to have 24, then 32, right? All these numbers are multiples of 8. So the first 2 multiples of 8 is just going to be 8 and 16. So we have 8 and 16, right? Make sure either write them with a comma or write the word and, right? So write 8 and 16. Now for part C, they want us to prime factorize. The first number is going to be 16. So they want us to prime factorize the number 16. So let's take a look at this, right? We have 16. Now they want us to use prime factors. So let's think about it for a second, right? We know what prime numbers are. Prime numbers are numbers that has 2 factors, 1 and itself. And we just wrote out a list of prime numbers up here, right? So the prime factorizes number 16. We're going to have to use prime numbers, right? Prime factorize prime numbers. Think of it like that, right? So when I start to prime factorize this, I'm going to do the tree method. So I'm going to multiply a prime number by another number that's going to give me 16. I know 2 multiplied by 8 is going to give me 16. So I have this prime number here. So I'm done with that side. Now I know 8 is not a prime number, but I do know that 2 multiplied by 4 is going to give us 8. So once again, I have another prime number. So we're left with this number 4. We can say that 2 times 2 is going to give us 4. So once we have this, we are now complete. So we have our prime factors. That's going to give us 16. We can write this as 2 times 2 times 2 times 2, which you can just write as 2 to the power of 4. So for the number 16, when we write this as a product of prime factors, we're going to have 2 times 2 times 2 times 2. Now we know we can just write all of this as 2 to the power of 4, right? So this is going to be our answer for this particular problem. Let's prime factorize the number 24. So we have 24. We know to get 24, we can say 2 times 12. We know 2 is a prime number. Now we have the number 12. We can say 2 times 6 is going to give us 12. We have another prime number. Now we have 6, right? We know 2 times 3 is going to give us 6. So we have our final 2 prime factors. Now that we have all of these factors, we can just write it out to be 2 times 2 times 2 times 3, which we can write simplified as 2 to the power of 3, because we have 2 multiplied by itself 3 times, multiplied by 3. So this is our answer for this particular problem. Let's write it in the space provided. We can write it as 2 times 2 times 2 times 3, or you can write it as 2 to the power of 3 multiplied by 3. Any one is going to be correct. Also, for this particular one, we know we have 2 multiplied by itself 4 times, so we can also write this answer as 2 to the power of 4. Okay, now let's do the third part of this. It says calculate the lowest common multiple of 16 and 24. So they want us to find the LCM, because we know LCM stands for lowest common multiple of 16 and 24. So let's write these two numbers out. We have 16, 24. Now when we think about multiple, we should think of our multiplication table, right? Just like how we did up here for the first 2 multiples of 8. Now we're always going to start with multiplying by 1. So let me just write this out real quick. I'm going to say 16 times 1 times 2 times 3 times 4 times 5, right? Now I'm going to do this really quickly. Now remember, there are multiple ways to solve these problems, right? So we have 16 times 1, that's going to give us 16. 16 times 2 is going to give us 32. 16 times 3 is going to give us 48. And 16 times 4 is going to give us 64. Now let's do for the number 24 now. We have 24 times 1. That's going to give us 24. Do we have 24 in this first row? No, we don't. So let's go on to the second multiple. 24 times 2 is going to give us 48. Do we have 48 in this first row of multiples? We do, right? We know 16 has a multiple of 48. And 24 also has a multiple of 48. So the lowest common multiple between 16 and 24 is going to be 48. Now you could have solved this by prime factorization as well, but because I just did prime factorization up here, I just want to show you a different method. So that's why we just did it this way, right? Now let's move on to the next question. Number 13, the question says evaluate. Part A, we have a fraction in brackets, and that's 1 over 5 times 2 over 5, close brackets, plus 1, 11 over 25. So we know, according to PEMDAS, we always want to work what's inside the brackets first. So because we have these two fractions in the brackets first, let's work that. I'm just going to write it in the rough work section. Now we know we're going to be solving for what's in the brackets first. Because we're multiplying fractions, it's very easy. We're just going to multiply the numerators, multiply the denominators, and reduce the fraction if we can. So we have 1 times 2, that's going to give us 2, over 5 times 5, that's going to give us 25. Plus, we have 1, 11 over 25. Now, anytime we're adding or subtracting fractions, what's the very first thing you must do? Anytime we're adding or subtracting fractions, the very first thing we must do is look at our denominators. So in this fraction, our denominator is 25, and in this fraction, our denominator is also 25. Therefore, we can just add these fractions. We know our first fraction does not have a whole number, right? So we have two ways we can go about this. We can either leave the first fraction and change this into an improper fraction by multiplying 25 by 1 and adding that to 11 and putting it back over 25. So that's one way we can do this problem. Another way we can do this problem is we can look at this and see the whole number for this fraction is going to be 0, right? So if you want to, you can write a 0 and then do 0 plus 1 and then add the fractions. So that's kind of the route I'm going to take with this, right? Now for the first fraction, even though we don't have a whole number, I'm just going to write a whole number in there. That way you can kind of see what's happening. So we have 0 for the whole number, 2 over 25, plus 1, 11 over 25. We know we're adding mixed numbers now, so I'm just going to add 0 plus 1, and I'm going to add the two fractions. So we add the two whole numbers, now we're going to add the fractions. So we put 0 in there to change this into a mixed number, and now we're just adding mixed numbers. 0 plus 1 is going to give us 1. Now we're adding fractions, right? We know anytime we're adding fractions, the denominator must be the same. When we look at this, we have the same denominator, so we're just going to write it back and add the numerators. We have 2 plus 11. So when we solve for this now, our answer is going to be 113 over 25. So this is going to be our answer for this particular problem. We're going to have 113 over 25. Now, of course, if you got the answer 38 over 25, that would also be correct. So this is just the improper fraction version of this mixed number 113 over 25. Now let's do part B. It says 21 over 3 divided by 21 over 24. Now for this particular one, we have to convert the mixed number into an improper fraction, right? Because that's the easiest way to divide fractions. We have to convert the mixed fraction into an improper fraction. So let's first do that, right? I'm actually going to solve this one right here. I'm going to solve it right underneath it. So when we convert this mixed number or this mixed fraction into an improper fraction, we're going to multiply 3 times 2, and we're going to add it to the numerator. So 3 times 2 is going to give us 6. 6 plus 1 is going to give us 7. So we have 7 over 3 divided by 21 over 24. Now you must remember the rules for dividing fractions. The first rule is going to be to keep the first fraction, change the division sign to multiplication, and flip the second fraction. So we're going to flip this fraction. So now we're going to have 24 over 21. Now when we look at these two fractions, we can now start to simplify this, right? We know 7 can go into 7 one time, and 7 can go into 21 3 times. We also know 3 can go into 3 one time, and 3 can go into 24 8 times. So when we look at this, we're actually going to be left with 1 over 1 multiplied by 8 over 3. And we know how easy it is to multiply fractions. We just multiply the numerators, multiply the denominators, and simplify if needed. So we have 1 times 8, that's going to give us 8, over 1 times 3, that's going to give us 3. So our answer for this particular problem is just going to be 8 over 3. Of course, if you wrote it as 2 over 3, that will also be correct. Okay, let's move on to the next question. So number 14, part A says simplify. They give us this expression. So we have 5g plus 3, open brackets, 2f minus g, close brackets. Now we know even though there isn't any operation or any sign in between this 3 and the stuff in brackets, we know this is going to mean multiplication. So what we're going to do first is we're first going to distribute this 3 to all of the terms in this bracket. So when we distribute this, we're going to have 5g plus, now we're going to multiply 3 times 2f and then 3 times negative g or minus g. So 3 times 2f is going to give us 6f. Now we have 3 times g. Even though there isn't any coefficient in front of this g, we know it's going to have a coefficient of 1. So really, we can say 3, right? 3 times minus 1. That's going to give us minus 3g. So now that we have distributed this 3, let's begin to simplify. Now when we look at this expression, we have 3 different terms. We have 5g, we have 6f, and we have 3g. In this particular expression, do you see any like terms? Well, when we look at this, we know we have 5g and minus 3g, and these 2 terms are going to be like terms. So let's now combine these like terms. So we can rewrite this to be 5g. Now we know when we combine like terms, we're also going to take the sign that is in front of that term. So because we have minus 3g, we're going to bring that over with us. So we're going to have minus 3g plus 6f. Okay, now let's combine these terms. We have the same variable g, so we're just going to subtract these coefficients. We have 5 minus 3, that's going to give us 2g plus 6f. So in the answer space provided, we're just going to write 2g plus 6f. Of course, you can also write this as 6f plus 2g. Okay, let's do part B. Part B says factorize completely. So they want us to factorize this expression, which is 12a plus 8ab. So we have to factorize these 2 terms, 12a plus 8ab. Now, when you hear the word factorize, what do you think about? Factors, right? So we have to find the highest common factor between these 2 terms, and we're going to look at the coefficients, which is the numbers, and the variables, which is the letters. So let's begin. We have 12 and 8 for the numbers or for the coefficients. Now, what is the highest common factor between 12 and 8? Well, think about it, right? We know the factors of 12 are going to be 1 and 12. Then we have 2 and 6, and 3 and 4. So these are all the factors of 12. Now for the factors of 8, we have 1 and 8. We have 2 and 4. And these are all the factors of 8. So the highest common factor between 12 and 8 is going to be 4. So the highest common factor between these coefficients is going to be 4. Just going to write 4. Now let's look at the variables, right? So when we look at the variables, we're just going to see what do they have in common. So they have an A and an A. Now this one has a B, but this term does not have a B. Therefore, the highest common factor when dealing with the variables now is just going to be A. So we have found the highest common factor between these 2 terms. So now in brackets, we're going to have to write an expression that when we multiply that expression in brackets times what we factorize, it should give us our original expression. So we have open brackets. Now, we know we have 12a for our first term, right? We factored out this a, but we have 12. What times 4 is going to give you 12? Well, you know 4 times 3 is going to give you 12. So we're just going to write 3 for our first term. And like I said, we factored out the a already. So we don't have to write back any variable for our first term. So we have 12. And if we was to multiply this, 4a times 3 is going to give us 12a. So we have 3 plus. Now for our second term, we had 8. We factored out a 4. What times 4 is going to give you 8? Well, you know 4 times 2 is going to give you 8. So for our second term, we're going to have a 2. We factored out the variable a. So now we're only going to be left with the variable b. So we're just going to write back b. close brackets. So this is going to be our answer when we factorize this expression 12a plus 8ab. We're going to be left with 4a, 3 plus 2b. So now let's do part C. It says solve for h. So this is an equation, right? And we know this is an equation because it has an equal sign. Now when we look at this, it says 3h plus 4 equals 13. And because they want us to find for h, that means they want us to get h by itself. So they want h on one side of the equal sign by itself. So the first thing we should do is we should move this plus 4 over to the next side, right? So when we move this plus 4 over to the next side, we're going to be left with 3h equals 13, right? And when we move this plus 4 over, the sign is going to change. So because it's plus, when we carry it over, it's going to become minus. So we have minus 4. When we simplify this, we get 3h equals 13 minus 4 is going to give us 9. Now remember, they didn't ask for 3h. They wanted h. We know, even though there isn't any sign in between these two, that this means multiplication, right? So because this means multiplication, we're going to have to perform the opposite operation. Well, that's division, right? So we're just going to divide both sides by 3. Because we want to get rid of that coefficient. So these two 3's are going to cancel out. Therefore, we're going to get h equals 9 divided by 3 is going to give us 3. So in the answer space provided, we're going to write h equals 3. So now we're on number 15, and this one is a little different. They give us this graph, right? Part A says use a ruler and a pencil to join the points A, B, C, D in order to form a quadrilateral. So when we look at our graph, we see they labeled 4 points. They labeled A, B, C, and D. Now for part A, they want us to use a ruler and pencil to join the points A, B, C, D in order to form a quadrilateral. So that's all we're going to do. We're just going to join these points using a ruler. So we know we're going to join A to B. Then we're going to move the ruler. We're going to join B to C. We're going to join C to D. And finally, we're going to join D to A. Okay, so this takes care of part A. So we were able to use a ruler and draw a line to connect all of these points to form this quadrilateral. Now for part B, it says draw in the 2 diagonals of the quadrilateral. So we must be able to know what this word means. What does diagonal means? Now we know a diagonal is just going to be a straight line that joins 2 opposite corners. So for example, what are the 2 opposite corners in this particular shape? Well, we know B and D are opposite and A and C are opposite. So we're just going to use our ruler to draw in these diagonals. I'm going to start with B and D. And now we're going to draw the other diagonal, which is going to go from A to C. Okay, now that we have that, part B is complete. Now, part C says, write the coordinates of the point where the 2 diagonals intersect. So we're going to look back up, and we're going to see where these 2 diagonals intersect. Well, we can see these 2 diagonals intersect right at this point. Now, what is the coordinates of this point? Well, we know the x coordinate is going to be -2, and the y coordinate is going to be +2. So when we write the coordinates of the point where these 2 diagonals intersect, we're going to have -2 for the x and +2 for the y. So we successfully solved this problem, which is question 15. Now we have one more problem, and that's going to be question 16. Number 16 says, calculate the size of the angles marked by the letters. So they want us to find the size of this angle right here. So they want us to find angle N. Now when we look at this, what shape is this? This is a triangle, right? Now we have different types of triangles. We have equilateral triangle, we have isosceles triangle, and we have scalene triangle. So we know an equilateral triangle, all sides and all angles must be equal. We know for an isosceles triangle, we have two sides equal, which means those two angles are going to be equal. And for a scalene triangle, all three sides are different, which means all three angles are going to be different. Now when we look at this, we know this is an isosceles triangle because they have this dash right here between these two sides, which means that these two sides are equal, okay? So if this is 10 meters, this is also 10 meters, okay? Now this side is not 10 meters because it does not have this dash through that side. Now let me just erase this. So what I want you to do is I want you to label this triangle. Label it ABC. I'm going to use this point as A, this is B, this is C. Now I want us to find the opposite side of each point that we label. So for A, I know the opposite side of A is going to be this side right here. I know the opposite for B is going to be this side over here. Do you see that? So just look at it like this, right? We're just going this way. So that's going to be B. And the opposite side for C is going to be this side right here. Now, how did we get that? Well, think about it, right? We know B, the opposite side of B is going to be going this way because this is where point B is. The opposite side of C is going to go this way. That's where we labeled C. Okay, now that we have this, now because we know that these two sides are equal, we also know that these two angles are going to be equal. So if the length of side B and side C are equal, that means angle B and angle C are also going to be equal. Now we know angle B is 73 degrees, right? Therefore we know angle C is also going to be 73 degrees because they're equal. Now when we look at this, they want us to find angle N, right? Which is this angle here. How do you think we should find angle N? Well, remember, the interior angles of a triangle must add up to 180 degrees. I'm going to say it one more time. The angles in a triangle must add up to 180 degrees. If we know two of the angles, to find the third angle, we can just add those two angles that we know and subtract from 180 degrees. So let's do that, right? So we can write it multiple ways. We can write it as, we know angle N plus 73 degrees plus 73 degrees, which represents angle B and angle C, right? Must equal to 180 degrees. So that's basically the equation to find angle N. Now, like I said, I know we're just going to add these two angles and subtract from the total sum of angles in a triangle, which is 180 degrees. So I'm going to write it as 73 plus 73. 3 plus 3 is going to give us 6. 7 plus 7 is going to give us 14. So we know the sum of these two angles is 146 degrees. So to find angle N, we're just going to subtract this from 180 degrees. So we can say 180 degrees minus 146 degrees. We have 0 minus 6. We're going to have to borrow. 8 is going to become 7. 0 is going to become 10. 10 minus 6 is going to give us 4. 7 minus 4 is going to give us 3. And we know 1 minus 1 is going to give us 0. Therefore, we know angle N equals 34 degrees. So this is going to be our answer for part A. So in the space provided, we're just going to write N equals 34 degrees. Now let's do part B. Now for part B, they also want us to calculate the missing angle, which is angle M. Now when we look at this, what shape is this? Well, this is a quadrilateral, right? Now tell me, what do we know about the angles in a quadrilateral? Angles in a quadrilateral must equal to 360 degrees. Now we know what is a quadrilateral, right? A quadrilateral is a polygon that has 4 sides. So for example, a square, a rectangle, a rhombus, a parallelogram, all of these are quadrilaterals because they have 4 sides, which means that the total sum of angles in that particular quadrilateral must equal to 360 degrees. So to find angle M, I'm going to write an algebraic equation to explain what I just said. I'm going to start here. We have M plus this angle is 87 degrees plus we have this angle, and even though we don't have any numbers to tell us what this angle is going to be, we know this symbol right here is going to represent a right angle, which means this angle right here is actually 90 degrees. So we know this is 90 degrees. So we have plus 90 degrees plus 110 degrees, and all of that equals to 360 degrees. So we can just solve for this, right? We know we're just going to add all the sides that we know and subtract from the total sum of the interior angles, which is going to be 360 degrees. So now I'm just going to add the angles that we do know, which is 87, 90, and 110 degrees. When we solve for this, 7 plus 0 plus 0 is going to give us 7. 8 plus 9 is going to give us 17. 17 plus 1 is going to give us 18. So we're going to write the 8, carry the 1. Now we have 1 plus 1, that's going to give us 2. Therefore, we know we have M plus 287 degrees equal 360 degrees. So to find M, we're just going to carry plus 287 degrees over to the next side. So we can write this as M equals 360 degrees minus 287 degrees. When you solve for that, M equals, so let's subtract. We have 360 degrees minus 287 degrees. 0 minus 7 can't go, so we got to borrow. 6 is going to become 5. We're going to carry 1. 10 minus 7 is going to give us 3. 5 minus 8 can't go, so we got to borrow. 3 is going to become 2. 5 is going to become 15. 15 minus 8 is going to give us 7. And 2 minus 2 is going to give us 0. Therefore, we're going to be left with 73 degrees. So we can say M equals 73 degrees. This is going to be our answer for this particular problem. So in the space provided, we're just going to write M equals 73 degrees. Congratulations! We've successfully solved the BJC Math Paper 1 exam for the year 2020. As you can see, some of these questions were a little more challenging than others, but the main thing behind this is you had to go and understand some of the concepts, right? It's not just about answering questions. It's about understanding the concept behind each question. If you can read a question and understand what it's asking for, and you understand the concept behind that particular topic, you will have no problem solving these questions. Alright, don't forget to like, comment, and subscribe. Link up, students.